Once Kate's kite reaches a height of 52 feet above her hands, it rises no higher but drifts due east in a wind blowing 3 feet per second. The question is, how fast is the string running through Kate's hand at the moment she has released 103 feet of string? For this problem, I'm going to try to draw a simple diagram. So to keep it simple, this is going to be like where the kite starts from her hands, and we're told it reaches a height of 52 feet and it goes no further. So this length is 52, and that's in feet. We are told that the kite is going to drift, I'll say east going this way, so I'm going to represent that with a little bit of length here. And finally, when we're asking about how fast is the string running through Kate's hands at the moment she has released this much string, we're talking about the distance from here to here and how fast this is moving. So I'll draw this in here like this. And it's important to note that we get a right triangle. The question asks that we put the horizontal distance here with the variable x, and the distance from Kate and the kite as z. In terms of what this question is asking for, it's asking us to find the rate at which the length of z is changing. That's how fast this is moving. And specifically, when she has released 103 feet worth of string. In this problem, we are told that there's a wind blowing due east at 3 feet per second, so that's dictating how quickly the kite is moving in this direction. So that is how fast x is changing. So dx dt is equal to 3 feet per second. All right, so we need first an equation that is going to connect these two variables with this number. And what we're going to use is the Pythagorean theorem. The square of this side plus the square of this side equals the square of the hypotenuse. So I'll write that as 52 squared plus x squared is equal to z squared. The next step is, once you have your equation, take the derivative of both sides with respect to t, and let's see what that gives us. So I'm going to rewrite the equation. So that's 52 squared plus x squared is equal to z squared. If I take the derivative of the left side, I would start by differentiating this. Even though it's squared, this is just a number, so the derivative is 0. We move on to the next piece. Okay, it's a variable to a number, so I can bring the 2 down front, copy down the x, subtract 1 from the exponent, which is a 1, which I won't write. But since we're differentiating with respect to time, we have to multiply by the derivative of x with respect to t. So that comes out by the chain rule. If I do the same thing to the other side of the equation, I'll get 2z to the first times dz dt. So here I have differentiated my equation. I don't need to write this plus 0. I'm seeing there's a 2 on both sides of my equation, which can be canceled. So if I simplify this thing, I get x dx dt is equal to c dz dt. So the ultimate goal was to figure out how fast this side is changing at this given moment when the length of z equals 103 feet. So let's see if we have enough information to plug into this formula to solve for dz dt. So again, I don't know this thing. We are told that, okay, this should be 103, so I'm going to start plugging this information in. So this is going to be 103 times dz dt. On the other side of my equation, we are also given dx dt, that was 3. But I guess we don't know x at this moment. I think we can solve for it though. even though we don't know or we weren't given what x is equal to, if I put 103 into this equation, it will allow me to solve for x. So I'm going to do that off to the side. So that is, what does x equal? Well, 52 squared plus x squared should be equal to 103 squared. I will subtract 52 squared from both sides of the equation. And then x should be the positive, since we're talking about a distance, the positive square root of 103 squared minus 52 squared. And I'm going to get this value directly from my calculator. So the square root of 103 squared minus 52 squared is, okay, I'm going to round this, I guess, to maybe 2 decimal places. But I'm getting that x, it's approximately 88.91. So I'll put this value now in place of x. That is 88.91. To solve for dz dt, I will divide both sides by 103. So my answer should be 88.91 times 3 all over 103 is the rate at which the side z is changing. So I'll round this to, again, just doing this portion directly in my calculator. So 88.91 times 3 divided by 103. Okay, if I round to 2 decimal places, the value I get is 2.59. Now, what are the units on this? They should be feet per second. So this is the rate at which the length of this side is changing the moment that z achieves a distance of 103 feet.